In today's lesson, we are going to be reviewing the right-angled trig concepts that we've looked at so far. Right, so again, the right-angled trig should be a review from grade 10, but we're going to review it again, even though we've looked at the two lessons on finding a side length and finding an angle using right-angled trig. We're just going to review those concepts again. So just to review, SOHCAHTOA, right, that's the acronym that lets us kind of figure out what our ratios are supposed to be, right? S for sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now you will get the formula, so you don't have to worry about memorizing it, but just to kind of do it quicker, you can use that acronym. We did talk about finding side lengths and solving for angles, right? And there were a couple different scenarios that we came across. If we have the missing piece on top when we're trying to find a side length, so that would look something like, say, x over 10. That's what we mean by the missing piece on top. The kind of the shortcut, bring up and multiply. So kind of the shortcut of what we have to do is bring up and multiply. If the missing piece is on the bottom, so that'd be something like, say, 10 over x. So there the missing piece is on the bottom, the unknown is on the bottom. We switch and divide. So we switch that unknown with the ratio and the angle, and then we divide the numerator by whatever the ratio or whatever the trig ratio and the angle happens to be. So again, kind of a shortcut, just kind of a phrase maybe you can remember of what you have to do. And then finally, solving for angles, we always use the inverse. So the inverse would be something like sine -1, right? Or cosine -1 or tan -1, right? That's what we mean by the inverse of sine -1, cos -1, tan -1. Those are all things that we might, that we could use depending on what sides we're given to find an angle. So for just an example, the trig ratios for angle A and triangle A, B, and C. So we're using, or we're referring to, we're referring to this angle here. That's angle A. So we want to figure out what is the sine ratio for angle A. Well, again, when we're coming up with our ratios, we need to first make sure we're labeling our sides. Right, so across from the 90-degree is our hypotenuse, so that would be side C. Across from our reference angle is our opposite, and then we have the adjacent as the last one. So for sine of an angle, right, is opposite over adjacent. In this case, our opposite is side length A, opposite over hypotenuse for sine. So A over C. So side A over side C. Cosine is the adjacent over the hypotenuse. So the adjacent is represented by side B, and the hypotenuse is side C. For tan, opposite over adjacent, so that is side A over side B. So that's all that question wanted us to do. Just kind of get used to understanding, if I use my reference angle, I've labeled my triangles, what would the sides happen to be? Or what would the ratios happen to be? Our first example, we want to calculate the length of side A. Again, we want to make sure we label our sides. That's the first thing we should always do with right-angled trig. We see our 90-degree angle, so across from that is the hypotenuse. We see our reference angle. It is the angle that we're given. If we're given both of the other angles, you can choose whichever one you want to use, just making sure that you recognize that you might have to relabel your sides depending on if you switch up the angle. So our reference angle here, so that means across from that is our opposite, and the last side is the adjacent. We are dealing with the opposite and the hypotenuse. We're given the hypotenuse, we're looking for the opposite, so that means we are using sine. So I'm going to write out my formula. Sine of an angle is equal to the opposite over hypotenuse. Sine of our angle is 20, so sine 25 is equal to x, or side A, over 12. Here, this is a scenario where the missing piece is on top. So that means I bring up and I multiply. So we have 12 times sine 25, which will be equal to side length A. So 12 times sine 25 is 5.07, or you could just say 5. So that is our missing side length. Move these pages down. For number 2, again, calculating side length A, here we don't see anything labeled. So if we're asked to find, a side length, right, and we're told A or B or C or whatever it happens to be, we want to look at the angle or find angle A. So side length A is going to be across from angle A. So if this is angle A, this is side length A. Right, so this is the side length we're looking for. Now we can label our triangle for the 3 sides: hypotenuse, opposite, adjacent. Across from the right angle is the hypotenuse. 35 is my reference angle, so across from that is the opposite. And then that means the remaining side is the adjacent. If you prefer to redraw the triangle into a method or into a rotation that you feel more comfortable with, you're more than welcome to do that. Just make sure you label everything properly, or you place the information in the correct spot when you redraw it. So because we are looking for A, we are using the adjacent. We are also given the hypotenuse. So A and H is cosine. So I'm going to write out my formula. Cosine of an angle, or cosine theta, is equal to adjacent over hypotenuse. I'm going to fill in my information. So cosine 35 is equal to adjacent A over 15. Again, another similar scenario, missing pieces on top. So we bring the bottom up and we multiply. So 15 times cosine 35 is equal to A. And we get 12.3. Again, for rounding, if you want to round to the nearest whole number, that is fine as well. Unless, of course, the question asks you to be specific, rounding it to 1 decimal place or whatever it happens to be, then you kind of have to follow suit with that. Another side length example. So again, we want to label our side, or first it says side length M, or side M. So let's make sure we know what side we're looking for. So side M, we see angle M over here. Side M is across from it, so that's the side we're looking for. We do have to label our 3 sides. Across from the 90 is the hypotenuse. Across from the angle is the opposite. And the remaining one is the adjacent. In this case, we are dealing with O and A. So so O and A is tan. So again, tan theta equals opposite over adjacent. We're going to fill in our information. So tan theta equals not tan theta, we know the angle. Tan 40 equals M over 10. And this is very similar to the last one. Bring up and multiply because the missing piece is on the bottom, or on the top, sorry. So we have 10 times tan 40 equals M. And we get 8.4. So 3 different versions of finding a side length. We've used the 3 different ratios. Now they are all the same method, so make sure you are going back in your notes to solving for side lengths and looking at the other method as well, just so that you're familiar with the 2 versions or the 2 scenarios you might come across. Lastly, we're just going to look at an example for finding the measure of an angle using right angle trig. So here it says calculate the measure of angle B. It's already labeled for us with theta, the unknown angle, or the symbol for an unknown angle. But angle B, we just look at the point, we look for the capital letter B. Once I know what I'm looking for, I'm going to label my 3 sides. across from the 90 is the hypotenuse, across from the angle is the opposite, beside the angle is the adjacent. The two sides that I'm dealing with in this case are H and A. If you were given all three sides and asked to find a side length, you can pick whichever two sides you want. Or sorry, if you're given all three sides and you're asked to find the angle, you can pick whichever two sides you want, and then use that as the appropriate ratio with the two sides you picked. In this case, because we only have A and H, that is going to be cosine. So cosine of an angle is equal to adjacent over hypotenuse. I'm going to fill in the information from my diagram. So cosine of an angle, I don't know, equals 4/5. Now, I'm going to do this a little bit different from our lesson, and I'll show you kind of the two versions of it in the end. So if I want to get the angle or theta by itself, I'm going to move cosine over, and we get cosine -1 is of 4/5. Now this step right here, this is the formula that we were given in the notes. So if you jump right to that point and you start with that, right, because that's the formula we have in our notes, that's fine as well. So you could start with theta equals cosine -1 of adjacent over hypotenuse. You can start right with that formula. You're going to end up in the same spot anyways, of cosine -1 equals 4/5. So it's the same thing. One is just, again, more algebraic, the actual step-by-step process of doing it, whereas the other one is kind of using the formula that we were given, which already rearranges for what we're looking for. But we go through and solve, so we can just plug this into our calculator. Make sure you're using the cosine or the inverse button. You're not doing cosine to the power of -1, because that will give you something different. We'll round it so you get 37 degrees. And again, it doesn't matter which method you use, plugging in directly into our rearranged formula already, or rearranging the formula as you go. Again, make sure you understand, your calculator, make sure you're comfortable with your calculator. So when you are plugging stuff in, you know whether to use brackets or not. And also make sure your calculator is in degree mode when you're going through and solving these problems. So again, this is just a bit of review on right angle trig, looking at the different scenarios or some of the scenarios that you might come across, and just making sure you're going through those steps of labeling, determining the correct ratio, and then from there figuring out the best method to solve for your missing piece.